Let's jump into the exciting part and look at the Matrice 4 data. And obviously today we'll be using 3Dsurvey, which is the software of our choice, and start a new project. First off, starting our new project, we would obviously have to navigate to the correct folder, which I've already done. And then I will open up the folder. I'll click on the first photo, scroll down to the bottom, and then shift and click on the last photo. I'll open up the data, and then what 3Dsurvey then pops up is you can then select your coordinate of choice. Our current coordinate system is obviously in South Africa, and we use the RTBS hook LO29 system, and the EPSG is 2053 for those who are looking for the EPSG code. We're obviously also using the South African datum for our joid, and then I can go ahead and click on import. As I can see, the data was successfully imported. And now this brings me to the very exciting part of looking at my Matrice 4 data. And as I can see here, my Y precision is 3 mils, X precision 3 mils, and horizontal precision is about 8 mils. And that is really good. For any guys interested in buying a drone, this is the reason why you are considering the Matrice 4. I'll scroll down just to make sure that there's no pictures that were taken that are not within tolerance. No, all of them look good. So this then brings me to a very nice and exciting part. Over here you can see that the grid was actually for this whole field was about 4 lines. As I zoom in closer, we can see that there was 3 pictures taken per position that the drone has identified. And yeah, it will be interesting to see how much data of the surroundings we will be able to capture with the Matrice 4 on the smart oblique function. Normally the same field is quite a number of lines, but obviously with the smart oblique function it reduces the amount of lines to literally just 4 lines. So the first step in 3Dsurvey that I want to do now is I'm satisfied with my data, and I can now move over to a bundle adjustment. So for bundle adjustment, our go-to setting here is global because it's not a lot of data, and yeah, obviously we want to use the telemetry that the drone outputs because it's really good. And yeah, we wanted to maybe also keep it there on auto on the orientation. If the software does detect a better camera position, we want the software to have the ability to manipulate that. So once I'm done, I'm going to click on OK. And then the bundle adjustment will just run. It will go through a few basic steps, like where it started now. It's running the feature extraction. So what we'll get after this is a very small sparse point cloud that we'll be able to have a look at. And what I would like to show you guys is just how the smart oblique function with the Matrice 4 actually works. Alright, as you can see, it's currently finished with our sample point cloud. Just to give you a little bit of a broader overview, here you can actually see a bit more of a sample data set that was produced. Alright. And this is actually what I wanted to show you guys. If you look at the way the camera is tilted and angled, we can actually see that our first camera image is a top down and then a left and a right orientation. I hope I can position this a bit better. So here 3Dsurvey shows you more or less what the angle of the pictures were when they were taken. Now, so we can see a clear left, right, and then a clean top-down picture as well. Alright, because we want to really test the accuracy of the Matrice 4 here, we are going to go ahead and reconstruct this dataset without using any orientation points or GCPs, and let's see what the results look like. I'll go ahead and click on reconstruct. For this I'll do it, I'll process the reconstruction on high, not extreme, it's not needed for this case, but let's look at the data Maybe medium will be even faster. All right, so let's process it and then we'll look at the data and analyze the accuracies of the GCPs that we have placed around the site. Great, as you can see, the software is finished processing, and yes, we can really just see how much extra data there is actually surveyed by these small lines going back into our original imagery data. Looking at the map, we can really see it's actually a really small area that we have selected, and looking at the processing, we can see it's really so much more. It's almost double towards the site that was actually also processed and that we are able to extract data from. So the smart oblique function on the Matrice 4 is really a next level game changer. But before I say that, let's first go verify and look at the accuracies. So before we can do that, we just quickly need to calculate a new top-down image. This will just help me when I zoom in to get clarity on exactly where the points are that I am interested in selecting. So going back to my orthophoto, I would also want to quickly generate a mesh. And then I would like to drape this mesh with an orthophoto. Great. Now I'll just jump into my CAD function. I'll click on the point snapper, and then I'll zoom in here. As I can see, there's my first GCP. I'll make sure to select as near as possible in the middle and go out to my next one. So this is just to really verify what is the actual accuracy that we can achieve with the RS2 Plus, combine it with the Matrice 4. Let's look at the total accuracy. Just to snap as accurately as possible there. Last point. Alright, so I've selected these 4 points. Let's go and export the data and look how they actually compare in Excel. Alright. So I'll export this as a text file. So we have also already, when we were in the field, measured the GCPs with a Reach RS2 Plus, and we'll now go and look what is the actual accuracies that we have achieved. Alright, so I've created a results folder. Okay, so if I compare my GCPs with each other, so this is the actual measured coordinates from my RS2 Plus base and rover, and this is the actual coordinates that we extracted from 3Dsurvey itself. And over here we can actually see the residuals are really spot on, and that's incredible. So getting those type of accuracies on a drone normally was not possible, but we're very excited to announce that without any additional correction, we're able to achieve, like, the maximum on elevation is about 2 centimeters, and obviously the position could be off just on the way that I selected the points, but I'm very sure with a small marginal computation, or just even making sure on the actual points how I selected the points, that you'll be able to get this even to as close as 1 centimeter on the position, and I'm quite happy on a 2 centimeter elevation on the drone data for sure. As we can see, the Matrice 4 honestly outperformed our expectations. without even using GCPs for our correction, we were able to get about 20 mils in height total error, and obviously even better on position error. I think if we move the point out around a bit, that would have been sub-centimeter accuracy on position. That's uncorrected data without using GCPs. So we're really impressed with the Matrice 4 and we're excited to make sure that it gets into your hands.